from Group 5, and in this video, my group will talk about thermal conductivity experiments. The goal of this experiment is to evaluate the thermal conductivity of a group of specimens initially, in addition to calculate the heat conductivity of various building materials, and to determine thermal resistance of materials. So, what is the thermal conductivity? Thermal conductivity refers to a material's inherent capacity to transport or conduct heat. It is one of the heat transport techniques, the others being convection and radiation. Heat transfer process can be measured using rate equation. This heat transfer modes rate equation is based on Fourier's law of heat conduction. Thermal conductivity also defined as the amount of heat per unit time per unit area that can be conducted through a plate of unit thickness of a given material, the phase of the plate differing by 1 unit of temperature. Besides thermal conductivity occurs through molecular adhesion and contact and does not result in the bulk movement of the solid itself. Heat moves along a temperature gradient, form an area of high temperature and high molecular energy to an area with a lower temperature and lower molecular energy. This transfer will continue until the temperature reaches thermal equilibrium. The pace at which heat is transmitted is determined by the magnitude of the temperature gradient as well as the material's specific thermal properties.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Shazan Amali bin Jamaluddin and my matrix number is AA200277. And now I'm going to talk about the recognition of heat conductivity of solid. There are two things that I will talk about, which is pre-setup and safety measures. First, the pre-setup. The steps are check either all the equipment and all the instrument is in a good condition. Check whether there is a defect or not on the specimen that will be used. Next, make sure the system source can operate at a maximum temperature of 200 degrees Celsius. Make sure the system operates at 110 volts at AC power supply. Lastly, keep the system running for a while until both heat source and heat sink temperature are become stable. Then next, the safety measures. First, don't open the machine once the experiment started. These steps are a must to avoid injury from the heat or from delay the result of the experiment. Next, close the power supply when the data has been collected and turn it back on when the next specimen are in the machine. Lastly, wear a heat-resistant glove when the specimen are ready to be taken out or when you put the specimen in the machine. That's all for me. Thank you.
Greetings. My name is Dodimotipo with matrix number AA200004 and 6. I'll be explaining about our demonstration in this experiment with the correct step and important precaution that you need to take. Before we clamp the specimen, make sure to measure all the dimension of the specimen that was used. Let's see this video to give you a demonstration. Next, you can now proceed to clamp the specimen into the machine. Here's a demonstration.
Toilet. Mana?
No, I can't.
After clamping the specimen into the machine, wait around 10 minutes. After that 10 minutes, you can proceed to record the temperature that you got and replace the specimen with another specimen. The same steps follow to the next specimen that will be replaced. Repeat this process until you are out of specimen. In our case, we have 4 experiments, specimen, so we repeat this experiment around 4 times with other different specimen.
Assalamualaikum. My name is Iqwan Hibim Asri and I am from section 5 group 2. Okay, I'm going to do a performing video where the subtopic is observation. So what we can observe from the experiment is based on data 1, where we have to see the changes afterwards test minute for the plate that be given to us, like Duratec, PMMA, nylon and also PVC. After 10 minutes of the experiment, what can we observe is the decrease of the cold plate for each specimen, in the meantime the hot plate. Then we go for data 2, same goes with the experiment 1, where we have to observe after 10 minutes. The temperature of cold plate lowers, rises and decrease, and also decrease to stable, while the temperature of the hot plate climb and decrease. So the thermal conductivity test utilizing the guided hot plate method are prone to error due to the heat loss by convection at the exposed border of the samples. Furthermore, there are 3 factors that may contribute to the result of the experiment of single plate and multiply layers, where we need to combine 2 plates. The first factor is the gap between the plate and the hardened plate. The second is the imperfection of the featured insulation of the equipment that we use. The final factor that can contribute to the result are the temperature differential across the hull, as well as other factors which all contribute to the accuracy. There is a difference between the result for all the plates that we discuss in detail in result section. Now I will talk about the data for the single plate. For the nylon, the heat flux is 140, hot plate temperature is 45.2, cold temperature is 30.3, and thermal conductivity is negative 1.08 and thermal resistance 0.07. And for PVC, the heat flux is 247, the hot plate is 45.1, cold plate is 30.7, thermal conductivity is 0.489, thermal resistance is 0.06. And then we go for Duratec, the heat flux is 247, hot plate is 45.0, cold plate is 30.8, the thermal conductivity is negative 0.005, thermal resistance is 0.05, and the final plate is PMMA, where heat flux is 130, hot plate is 45, cold plate is 29.6, thermal conductivity is 0.938, and for the thermal resistance is 0.12. The result for the first specimen is Durata and PMMA The value of hot plate temperature is 45.0, cold plate 29.4. Some thermal conductivity is negative 1.943. Heat transfer rate is negative 170.5. Overall thermal conductivity is negative 0.09. Overall thermal resistance is 0.09. For PMMA and nylon, the hot plate temperature is 45.1, cold temperature is 29.2, some thermal conductivity is negative 2.346, heat transfer is negative 1.7, negative 146.7, overall thermal conductivity is negative 1.17, overall thermal resistance is negative 0.09. And then we go for the next specimen is nylon and PVC. The value of hot plate is 45.0, cold plate 29.5. Some thermal conductivity is negative 1.897. Heat transfer is 222.5. Overall thermal conductivity is negative 0.95. Overall thermal resistance is negative 0.07. For the final specimen is PVC and Duratec. The value of hot plate temperature is 45.1, cold plate temperature is 29.6. Some thermal conductivity is negative 1.494. Heat transfer rate is negative 231.6. Overall thermal conductivity is negative 0.05. Overall thermal resistance is negative 0.06. What can we conclude after we get the result and see the observation of the experiment is the difference between of the thermal conductivity for each plates like Duratec, PMMA, nylon and also PVC. The temperature of a Duratec, PMMA, PVC and also nylon was recorded over the time as a lot heat after being clamped with heating plate for 10 minutes. The graph of heat flux and the temperature is proportional based on Ferrier law of heat conduction. Ferrier law of heat conduction. The heat transfer place coefficient, area of the plate, and the temperature differential were in the strength set up by means of water approach factor that influence heat transfer, mass flow, and charge of water, specific heat capability of water, and the total time. Based on the experiment with single plate, PVC is good conductor thermal material while PMA is not a good conductor thermal. For the multiply layers, a good conductor is PVC and Duratec, while PMMA and nylon is not a good thermal conductor. The recommendation is in making more accurate result is to do maintenance for a machine once a month. If the machine is old, then buy a new one for the good result. And also make sure to follow all the procedures and make sure the machine is in good condition to have a good result. That's all from me. Thank you.